Welcome to Pomodoro Joe for Monday, June 12th, 2023. Today we're doing LeetCode problem 228, Summary Ranges. This is an easy problem. You are given a sorted, unique integer array, nums. A range from A to B is the set of all integers from A to B inclusive. Return the smallest sorted list of ranges that cover all the numbers in the array exactly. That is, each element of nums is covered by exactly one of the ranges, and there is no integer x such that x is in one of the ranges but not in nums. Each range, a, b, in the list should be output as, and then we have some strings, a with a little arrow pointing to b, if a doesn't equal b. Otherwise, it's just a as a string. Okay. All right. It's a little bit confusing, but we'll look at these examples here. So we have 0, 1, 2, 4, 5, and 7. So we can cover 0, 1, 2 as a range by going from 0 to 2. So we have this little arrow. We can cover 4 to 5 by covering 4 to 5 range. So that's got the arrow. And 7 is all by itself because there's no range in there to cover. So it's just 7. All right. So I think this is pretty straightforward. We already know that the array is unique and it's sorted, so we can just go from the beginning to the end, covering these ranges. So we have to figure out a couple things. So let's take a look at our constraints. We don't necessarily have any numbers to begin with, so that's one thing we'll keep an eye on here. And then the numbers can range from very small to very large. Okay, so we'll put 25 minutes on the Pomodoro timer and we will get started. And I think since this is an easy problem, this might be a good one to go through just general problem-solving techniques. So for this one, I don't necessarily know where I need to start. It's a little bit confusing, so let's just break this down into the pieces that we do know. So the first piece that I know is I need to return a list. So let's just start out with an empty list as our result. So we'll have a result, and that's an empty list. And we will return that result at the end. Let's see, what else do I know? Well, I know I have an edge case at the very beginning. We might not have any numbers at all. So we could do something super simple here. Just say, if we don't have any numbers, so if not none, then we'll just return the empty list. Okay, so that takes care of one edge case. What else do I know? Well, I know I need to return this array of strings. And in each string, I have a couple different pieces. I have each one of these ranges, and a range can have a start value, an end value, or just a start and end value, which are the same. And there's an arrow that goes in between. So I could do something like, maybe let's create a little function that creates this string for us given a start and end value. This might not be strictly necessary, but it could help. So we'll have something like this, get range string. And we'll pass in a start and an end. And this will be super straightforward. So we'll just say if start is equal to end, well then this string is just the start string. So we can just return, let's see, the string of the start. Otherwise, we need to return, let's see, it'll be the start string plus this little arrow string plus the end string. So it'll be the string of start plus this little arrow and plus string of the end. Okay, so now we have this little helper function that given a start and end will give us back the string that we'll put into our result array. Okay, so that helps us a little bit. Now we need to get into the actual problem. How do we solve this problem? Well, I do know based on this, I'll probably need some start and some end to keep track of. And I'll need to go through every number in our entire input array. So I'll need some type of loop, either a for loop or a while loop. Well, let's just start out with the pieces. So we'll have a start. We don't know what it is yet, so we can set it to none. We'll also need some end, and we'll set that to none. So we have a start and an end. And then we have to go through and figure out what these start and end pieces are. So let's have a for loop. I know I want to go through every number, so let's just go through every number in our input nums. So far, the num in nums. Now, breaking this down further, what could this number be? It could be the start, it could be the end, or it could be some number in between. How do we know? So the first thing we can do is, how do we know if this is a start? Well, we can check if we don't have a start, then this must be the start of a new range. So we can say, if our start is equal to none, then this must be the start number. So we'll set start equal to n. And then we can just continue, because we've set our start value and we have to look at the next number. This will be num. And how do we know if this is the end value? Well, we know we've reached the end if this number, num, is more than 1 away from the previous value in our array, which means that I think we might need to keep track of our previous value in the array. So let's have a previous value here. Also set that to none. So we know we've reached the end of our range if this num is greater than our previous value plus 1. Okay, so now we've reached the end and we can set our end equal to this num. But we haven't set our previous value anywhere. So where do we set our previous value? We'll need to set our previous value at least once in here. So let's set our previous value in here. And if we don't have a num that's greater than our previous plus 1, then we'll also need to set our previous value out here. And here we can also do a continue, because we found this end value. Okay, so I think this is starting to shape up a little bit. We'll go through. If we don't have a start value, then this number is our start value. We'll also set our previous value to this number so that when we go through the loop in the next loop, we'll have this previous number set. All right. So every time we go through the loop, if we have a start number, we'll set the previous number to this number. If at some point the number that we have is greater than the previous number plus 1, so we are more than 1 away from our last number, that means that this must be the end. And it also means that we need to basically wrap up this previous range and put it in our result. So our end will be this number. Whoops. And I think we also do need to set our start and our previous at this point, because we've just realized that, oh, actually, this end is not this number. This end is the previous. Interesting. So the end was actually our previous number, and this num right here, this becomes our new start. So start is equal to this num, and we also need to set the previous equal to this num. Okay. And we do need to, this point is where we've reached the end, we've figured out our end. We actually do need to get our range string and put it into our result here. So let's do that. I'll call it value for here. Get range string, and we'll pass in our start and our end, and then we'll add this to our result. All right, so this is shaping up. Now it looks like this continue, we are already setting our previous to this number, and then we're continuing. But we don't need to continue and do this. We could actually clean this up a little bit. Well, maybe I'll save that for later. Let's just go with the basics for now. Okay, so we're going through our loop. If we don't have a start, we're going to set our start. If we do have a start, but our number happens to be greater than the previous number plus 1, that means that we've skipped a number. So that does mean that we've reached the end. We need to add that range to our result. Then we'll restart our new range with this number. So this does mean that when we get to the very last number, we haven't actually run through sort of this part of the loop. We get to the last number, we have a previous value, we have a start, but we never actually hit the end because we ran to the end of our input array. So out here, we still need to take that into account. So we will have basically this piece outside of our loop. So we got to the end of our loop, we have some start, we have some previous, but we actually haven't set the end yet because we reached the end of our loop. So we'll just do this whole thing again. We've reached the end, our end becomes our previous, and then we'll grab that range and put it in our result. Wow, this is a lot of code for an easy problem, but we'll clean this up. Let's just see if this works first. All right, that works. Let's see if this passes all the tests. And we pass, and we do okay for our first try on this one. We get a 42% for runtime and a 26% for memory. That's not too bad. So let's just jump back here. See if we can clean this up a little bit. Well, one thing, we're always setting this previous. So this continue doesn't really help us. So we could do something like this. All right, so that's one quick little thing we could do. The other thing is we're setting the start. If the start is none, then we set the start in the previous here, or then we're setting the start in the previous down here again. We're also using this end equal to previous, but we only use the end once here. We could just pass in the previous, so we could get rid of this end altogether. Or we could get rid of the previous and just call it end. That might be easier. Yeah, let's do that. So, more cleanup. So we've gotten rid of this extra previous that we were setting here. Let's call this previous end. Let's get rid of this end. Let's just call our previous end, and we'll just keep updating our end. So basically, if we don't have a start, then we'll set both the start and the end to our number. So that's possible that both the start and end are the same number. Then every time through the loop, we'll just check against our current end. If this new number is greater than our current end plus 1, then we've reached the end. So we can just grab our value here, put it into our result, reset our start number, and this will reset our end. So again, we're just replacing our previous with end. So we'll be updating our end every time through the loop. And then we again don't need this. All right, that's cleaned things up quite a bit. Let's see if this does any better. This may or may not do any better. We got rid of one variable, a little bit cleaner. Oh, it does do better. So we get a 66% for runtime and a 64% for memory. So that's a pretty decent improvement in both cases, both in memory and runtime. All right, let's see. Another thing that we're doing here, we're always checking if start is none, but start is only going to be none at the very beginning, the very first time through our loop. Now, we already checked here if we don't have any numbers. And if we don't, we return the empty array. So we could set our start immediately to our nums at index 0. And we can set our end immediately to our start. So in this case, we're basically taking care of this. So we don't need this anymore. But it does mean that since we're already grabbing that first value out of the array, we don't want to do that value again here. We don't want to grab it again. So we're going to have to go through our numbers from the first element to the end. So we're skipping element 0 because we've already grabbed it out of here. All right, now we can do basically this whole thing. And I don't think anything else changes in here. Yeah, this is looking pretty good. And then out here, we still have our cleanup. This is a lot shorter than our initial result. Let's see if this does any better. All right. Oh, and it does far worse. That is surprising. So I would have thought this would do better. So we only beat 15% for runtime and 64% for memory. So it turns out that actually having that extra if in here was better. That is pretty shocking. All right, so there are a couple other things that we could do in here. I actually like this code better, even if it's not as efficient, apparently. It's cleaner, it's easier for me to understand at least. But there's still a bunch of things that we could do in here to make this a little bit faster or a little bit cleaner, depends. One thing we could do, maybe not cleaner, but to make it faster. We're constantly making function calls to get our results. Function calls have some overhead to them. There's a little bit of processing and memory overhead to calling this function every time. So we could move this whole thing into the places where we use it. In other languages, you can do something called an inline function. So you could use a keyword inline that will inline this function. So you could do that. It will make this a little bit less clean just because you'll be basically doing it once here and again here. So that's duplicating your code. But that's one thing we could do. The other thing we could do is instead of going through nums in our nums array like this, we could have a while loop with an index, and we could just grab values out of our nums at that index. We could start at index 1 if we wanted, go through the length of the nums, So there are things that we could do to clean this up, but I'm actually pretty happy with this code the way it is. I don't think there's a lot of extra stuff in here. It's pretty clean, it's pretty compact, it fits on one screen. It's only 30 lines of code. So yeah, I actually might just stop here. I think this is a pretty decent solution. If you'd like to check this one out, again, this is LeetCode 228. Give it a shot. You have basically this framework to start with. You can start with that. You could do it on your own from scratch. You can try to optimize it, try to get a better score. So our best score on this one was a 66% for runtime and a 64% for memory. See if you can do better. There's room for improvement on this. All right. Well, that is it for me. I hope you enjoyed this. Hope you had fun. Hope you learned something. Hope you can go out and write better code.